Alright, today we're going to just compare the difference between average speed and instantaneous speed. And so I give you two formal definitions. Average speed is what you've been working with in Algebra 1. This is the total distance traveled. So that'll be like the idea of absolute value divided by the total period of time that has elapsed. In physics, you probably heard this called displacement divided by total time. Graphically, if I was going to graph it, it would be the slope of the secant line, not the tangent line, the secant line, to your curve. Analytically, what we use is the absolute value of your distance. So we're looking at, that means that the absolute value means the total distance, not your current position, because you could have turned around, if you're traveling on a road trip, you could have turned around, did U-turns. We're looking at your total distance that you have traveled divided by time. And so let's say I'm going on a road trip. I'm driving back to my family in Maryland, and currently I went 100 miles. It took us 2.5 hours to go 100 miles, and so my average speed for that trip is 40 miles per hour. Now, as you know, I'm not going 40 miles per hour the whole entire time. I have to leave my house. I'm not starting off going 40. I start off going 0, turn the car on. We start going 0, 10, 15, 20, get out of my neighborhood, and so forth. Let's compare that to instantaneous speed. So this is related to the instantaneous rate of change that we learned about on a previous video. And what I mean by instantaneous is I want to know what is my current speed at a specific time. So if I were going to graph this versus a secant line, I'm talking about the tangent line. And so I'm looking at a specific, what is the slope of the tangent line at a specific point in time. Analytically, the way you use this is we do the derivative and we plug in that point like we did in the previous video. So let's I'm going to keep going back to my example. I'm driving home. After 10 minutes, I've managed to get on the highway, and I looked down at my speedometer, and it currently, right at that moment, reads 53 miles an hour. And so just like, even though my car trip, my average speed was 40 miles an hour, at that moment in time, I have 53 miles per hour. Now you have to be kind of careful, because there's going to be times where they might ask you, is there a moment in time, or what is the moment in time, where your average speed might equal your instantaneous speed. So think about my road trip. Is there going to be a moment in time where on my road trip where my average speed is going to equal, if I look at my speedometer, like, oh, I hit 40 miles per hour. So if you want to think about it as I'm getting to that 53 miles per hour, I'm merging onto the highway, and I start off, I had the light, and so I'm turning right on the light, kind of similar if you're getting on a Trinity Mills. You go right onto the exit, so you start off going 30 miles an hour, and then you're on the ramp, you're going 40. So at that, what is that moment of time where you hit that 40 miles an hour? As you are accelerating onto the highway. And so there's going to be times where they're going to ask us to find what is that moment in time where the average speed, find the average speed of my entire trip, and then compare that to my instantaneous speed, which is my derivative, and find that actual moment in time. So let's go through several examples. Please just go ahead and get your calculator out, because I'm going to show these. Most of the stuff is actually going to be through the use of the calculator. Alright, number one, a roller coaster has its largest drop modeled by the equation d of t is equal to 1.93 t to the third minus 31.82 t squared plus 113.83 t plus 158.65, where d of t is measured in feet and time is measured in seconds. And so since we have use for the calculator, I want to showcase a lot of the calculator features to help you. I suggest you use as much as the calculator as possible if you've been given it to you and you're able to use it. And try not to write as much on your paper as possible. If you're able to use a calculator, you want to use more than just the basic functions. And so that's why I want to showcase some of these features to you. And so let's first go to our y. Let's go ahead and plug in our function into y1. So I have 1.93 t to the third. Whoops, that's not what I wanted, right? 9.3 to the third minus 31.82 t squared plus 113.83 t plus 158. It's not 158.65. All right, I just want to make sure I have my right function. 1.93 t to the third minus 31.82 t squared plus 113.83 t plus 158.65. All right, good. So let's go ahead and do second quit. Now I want you to go down and look for the clear button, and to the left of the clear button is the vars button, so that's what I'm going to click on. So I'm going to go to vars, y vars, so this means variables, and since we're dealing with functions, not parametric or polar, we're going to go and click enter, and our function's been stored into y1. And what this does is, what this will return to you is the independent variable at a certain point. So if I went ahead and clicked y1 8, it's giving me d, in this case, d of 8. It plugs it in for you, so you don't have to even bother plugging into a formula or storing anything. The calculator already does this for you. So if you want to write, you could write d of 8 is equal to 20.97. All right. So for part A, what they're asking us to do for average speed is we're really just finding old school slope. And so I'm just going to go ahead and clear this out so we can get the whole thing. So I'm going to go ahead and do my y2 minus my y1. So I'm going to do parentheses. Again, go next to the clear button, hit vars, go over to y vars 1, and then I'm plugging in 8, and that's my y2. Again, go to vars, y vars, there's my function, y1. I'm plugging in my f of 2 or d of 2, go ahead and close parentheses, and then I'm dividing that by my 2x point, so 8 minus 2. So what this reads really is y2 minus y1 over x2 minus x1, and we hit enter. So what this is asking us is, you have to kind of be a little bit smarter than the calculator. It's giving us a negative answer. Well, if I'm talking about speed, does speed really care about direction? Because at this point it's telling me that my roller coaster is going down. Well, speed doesn't really care which way you go. It's the absolute value. And so you could just go ahead and write 42, ignore the negative 42, and just write 42.25. But if you really need to, if you really want to see what the absolute value is because you're just having a brain fart, you can go over to math, go to number, and then absolute value is on the first one. So we can do math and then absolute value. You can go to second, and then go to the minus sign, which gives you your answer, and it'll plug in the answer from the previous problem and hit enter. I do know that if you want, you can also go to second catalog, and it's the first one listed, absolute value, the first one listed. I think you can probably figure out the absolute value of negative 42.25 would be positive 42.25. I wouldn't even bother with this, but I wanted to show you some of the features. All right. And so in terms of our problem, we want to know what is the average speed from 2 to 8 seconds. So what we really were doing was the absolute value of d of 8 minus d of 2 divided by 8 minus 2, and we found that out to be 42.25, and our units are actually going to be feet per second. So feet per second. Part B, what is the average speed of the roller coaster from 4 seconds to 6 seconds? And so I could just go back to vars, y vars, and do all that, but it seems like it would be such a waste of time to rewrite everything that I have on the first line up there, y of 8 minus y at 1 of 2 and all this stuff. So why don't we do second entry? So hit the second button and then go over enter. You'll see the word entry at the top. And it gives us the previous entry absolute value. But if I hit that again, second, and then entry one more time, it pulls up what we've already entered. And so I can actually just go ahead and scroll to the right, or you can, if you want, you could have just scrolled up, hit the up arrow, And then we can scroll over and just replace our x values. Instead of 8, I'm going to put 6. Scroll over to 2. Instead of 2, I'm going to redo and put 4. And then I'm going to replace 8 with 6. And replace 2 with 4. And then hit enter. And so in this case, I now have negative 57.69. And again, I'm going to have to use the absolute value. So I'm hoping that you don't need to actually do absolute value of negative 57. I'm hoping that you could just use your brain and save time and just write 57.69. And so what we're doing is, what is the average speed? So we have the absolute value of d of 6 minus d of 4 over 6 minus 4, and that is equal to 57.69 feet per second.